Hi there, everyone. We're going to start with our number theory with module 0. I have had already my number theory playlist, but I see these pre-lessons or preliminary lessons to be very important before we start with our number theory course. So I'll call this module 0 since we will talk about a lot of things, which will include proofs. Okay, so that you'll be ready in number theory for proving already. So first off, we're going to start with the terminologies that we need in the field of number theory and in the field of pure mathematics as a whole. First, we need to understand what theorems are. So I'll call this 1.1. So a theorem is a mathematical statement that is true and has been verified to be true. So before we start with our proofs, we need to have these definitions, like I said, and theorems is one statement. It's a mathematical statement that is true. Okay, if it's not true, these theorems are formerly known as conjectures, by the way. Okay, they are formerly called as conjectures. Conjectures are what we call as open problems or open statements which can be proven to be true or proven to be false. Conjectures. Okay, so these conjectures are just open statements. It's there in the open. It's up to you to prove it. If you can't prove it and it's proven to be true, it will be converted into theorems. Okay, some of the famous conjectures are the twin prime conjecture, the Goldbach's conjecture, and the rest. Again, conjectures are open problems. Maybe you're watching right now. Maybe you can be the one to solve those conjectures. They're open, and then they can be changed into theorems. Theorems in mathematics are quite different from theories in science. When I say theory in science, they are statements which can be true for now or maybe false in the future, or maybe it can be true or false. In science, laws are the ones which are exactly true. But in mathematics, theorems, which is different from scientific theory, okay, theorems are statements which are really true. And how can we say that these statements are true? Because we provide proofs to these such statements. So proof, everybody, a proof of a theorem is a written verification which is unambiguous. Okay, it should be understandable and convincing to everyone. Okay, that shows that a theorem is definitely and equivocally, or rather unequivocally, true. Okay, so then this knowledge, okay, before we have this proof, this knowledge includes an understanding of meanings of the mathematical words. Okay, before you can effectively write a very convincing truth, rather proof, phrases and symbols that occur in the theorems and its proof. It is crucial that both the writer of the proof and the reader of the proof agree on the exact meanings of the words. For otherwise, there will be a level of ambiguity, okay, in forms. So some examples of theorems are the Pythagorean theorem. Okay, I think that's the most popular of them all. And a Pythagorean theorem can be given a proof to make sure that it is true. Okay, so again, first it will be a conjecture. It will just be a statement. You provide a proof to that, and then it will become a theorem at the end. Okay, next up, we need to understand what a definition is, and all the others here are down below. Maybe I will start here. Okay, so let's have this one by one. A definition is an exact, unambiguous explanation of the meaning of a mathematical word or phrase. So it's exact, it's unambiguous explanation of the meaning. Okay, we will elaborate these terms, theorems, and definition in the next two parts of this playlist again, and we'll be finally, and then after that, we'll be finally ready to write proofs. But before that, we need to also understand that there are also some other terms which are similar to a mathematical theorem, but quite different in its weight. Okay, so we need to be aware of this. Okay, that there are a number of words that may mean essentially the same thing as theorem, but are used in slightly different ways. So in general, a theorem is reserved for a statement that is considered important or significant, such what I have said, the Pythagorean theorem. Okay, a statement that is true but not as significant as a theorem is what we call a proposition. Okay, it's still true. It can still be verified. It may be given a proof. It can be given It can be given a proof, but it's not as significant as a theorem. Okay, a lemma. okay, is a theorem. It is a statement whose main purpose is to help prove bigger and higher theorems in the future. So we call that a lemma. Okay, it's still a theorem, but its main purpose is to help prove bigger theorems than itself. Okay, and the corollary is a result that is an immediate consequence, okay, of a theorem or a proposition. So you're given an original theorem, you tweak something out of that theorem, and what you have is a corollary. Okay, so that's it for today. I'm going to make sure that I will finish this introduction to number theory before we can even proceed to proving. So again, what we have learned today are theorems, terminologies, conjectures, proofs, definition, proposition, lemma, and corollary. As another form, I forgot this, I believe, we have what we call an axiom. To make it very short and concise, an axiom is any statement which is obvious. Okay, it's obvious to be true. Like for example, the commutativity or the associativity of things, closure of sets of numbers. So that's an axiom. So that's it for this video. I will be creating more very soon. Thank you very much for watching. Hope you would like and subscribe. See ya.